We've seen multiple reasons to need to care about the difference between expressions and equations. Here's another one. It's related to radicals. So an expression with radicals, given the expression root 9, this becomes 3 with no plus or minus sign. It was just an agreement because an expression has to represent one number. What number should it be? And it'll be the positive square root. It will be 3, no plus or minus sign. However, square rooting both sides of an equation, so given the equation x squared equals 9, square rooting both sides leads to this. You root the left side, so instead of just x squared, now it's root x squared, and we'll root the right side, so instead of 9, it's a root 9. However, you need to now introduce a plus or minus sign. Okay, so the plus or minus sign appears when performing the action of square rooting both sides of an equation. So in root x squared equals plus or minus root 9, the left side expression of root x squared can simplify to plain old x. Here the word for the left side, it's an expression, so just the left side, what's in yellow, root x squared, is an expression, and that will become x for the same reason that's way up here, that the expression root 9 becomes 3. On the right side, there's this expression plus minus root 9. The plus minus is already written, and then root 9 in blue becomes 3 in blue, right? So the right side of plus minus root 9 becomes plus or minus 3. So in the end, root x squared equals plus or minus root 9 becomes x equals plus or minus 3. So let's solve the equation. X squared plus 1 equals 10. Subtracting 1 on both sides, x squared equals 9. Square rooting both sides, we'll have square root of x squared equals plus or minus square root of 9. Now this step is shown in gray to say that to try to kind of indicate this is a step that people often skip writing, but you do need to write this step carefully if you're going to write it. Sometimes what people do is they'll, instead of writing this step, will take the previous step, the first line of the answer, which says x squared equals 9. We should stop with that and not write anything else on top of it, but people often just stick a root sign on each side without putting a plus or minus sign as their sort of way of saying, I'm going to root both sides, but that step would be incorrect then. And then as a final step, to simplify root x squared, you'll have x, and then on the other side equals, and the plus or minus is copied down, and then the root 9 simplifies to a 3. You may skip writing the step that's shown in gray, but please do not have a step that says root x squared equals root 9. This is missing the plus or minus sign. And if you took x squared equals 9, that first line of the answer, and just stuck a root sign on each side, it would look like root x squared equals root 9. So this would be taking the previous finished equation x squared equals 9 and writing a root on top of each side, right? So the first step, let's say it this way, the first step in which you square root both sides must have a plus or minus sign on one side of the equation, and you get to choose which side. So double check my answer. You'll notice that up at the top there is no line which has root x squared equals root 9 alone with a missing plus or minus sign. So let's solve x squared plus 1 equals 14. Subtract 1 on both sides, you have x squared equals 13. Square root both sides, you have root x squared equals plus or minus, because this is the first step that has a radical anywhere, because we're square rooting on both sides. It's the first step in which we've square rooted on both sides. Plus or minus root 13. Again, this line is shown in gray in case you might choose to not write this step in the future, but if written, it must look like this. And then finally, the left side simplifies. The right side doesn't, so the right side will just be plus or minus root 13. You'll notice if you compare it to the question at the top, root 9 simplified further to a 3, however, root 13 just doesn't simplify any further. Okay, so again, square rooting both sides is going to have a plus or minus sign on both sides, so on one side of the equation or the other. When you square root both sides of an equation, you need to put the symbol on one side or the other. And the reason why is because x squared equals 9 has two solutions, right? X equals 3 is a solution, x equals negative 3 is a solution, and this all deals really with the fact that when you take a negative number and you square it, that's a negative times itself, and a negative times a negative is a positive. So there's really, if you look at x squared equals 9, what number would you square to get 9? And that was a trick question to word it that way. It's not what number would you square to get 9, it's what numbers, plural, would you square to get 9? And because there's two values, right? One of those is 3, and another one of those numbers you could square to get 9 is negative 3. Okay, so square rooting both sides of an equation introduces a plus or minus sign. However, squaring both sides of an equation does not introduce a plus or minus sign anywhere at all. So let's look, for instance, at root x plus 4 equals 10. Now, for this equation, to undo the radical, to undo a square root, we're going to need to square both sides. Oh, by the way, the left side, you can't distribute the radical and turn it into root x plus root 4, or in other words, you can't turn it into root x plus a plain old 2. Okay, so the missing step when people do this is trying to turn root x plus 4 into root x plus root 4. If we could do that, and you can't, but if you could do that, then what's written in the middle there would turn into root x, then plus a 2. The problem is root x plus 4 doesn't turn into root x plus root 4, right? So there's a skipping of a step, and it's not about the skipped work. It's not about, the issue isn't about how much work is skipped. It's that somewhere along the process in what was skipped, there was a mistake, a real mathematical error done. Okay, so the turning root x plus root 4 into root x plus a plain old 2, sorry, typo, this would be okay. The real issue is turning root x plus 4 into root x plus root 4 is a problem. It uses a false formula. So how are we going to answer this question? Square both sides. There's no need for a plus or minus sign. If you were to write a step that looks like this in gray, great. So it's root x plus 4. That whole thing is squared equals 10 squared. If you choose to instead skip directly to writing the step where the square root and the square undo each other, so you just have x plus 4 on the left, and then 10 squared is just written as 100, great. You subtract 4 on both sides, you can get x equals 96. So square rooting both sides of an equation introduces a plus or minus sign, and then cube rooting both sides of an equation doesn't. Okay, so why? It goes back to a negative times itself is positive, but then a negative times itself is negative, so there's no need when cube rooting. So this is a place where people sometimes take the idea that when you square root both sides, you need a plus or minus sign, yes, but when you cube root both sides, no plus or minus sign. Oh, by the way, before getting there, just a friendly reminder, the exponent here will not distribute. That would be using a false formula, so don't do that. We just need to undo the cube on the left side, so let's cube root both sides, and we'll have cube root of x plus 10 cubed equals cube root of 8. The left side, if you, again, choose maybe not to write that step in gray. If it's helpful to write, you should write it. But the cube root will undo the cube, and you'll have x plus 10 on the left. And then on the right, cube root of 8 is going to simplify to a 2. Subtract 10 on both sides, you get x equals negative 8.